Alright, welcome to Q&A number 2. My name's Sloppy Jugal, aka Zach, and let's get started. Alright, so in this Q&A it's kind of a little different. It's kind of like I found some cool stuff online that I thought would be interesting to discuss, and I was like, you know what, let's discuss it. So that's what's happening. Question number 1, microplastics. So the effects of microplastics on the marine environment hasn't really been studied a lot. There's not a lot of research that goes into what their effects are or how they affect the marine environment per se. Before I answer this question, I need to discuss to you what exactly is a microplastic, because I feel like, and this is probably an over-exaggeration, not a lot of the population understands what really microplastic is. So, microplastic is any type of plastic, crazy right, that is 5 millimeters in length. Now this could have been caused by degradation over time, or they could have started out at 5 millimeters or less, such as microbeads or small pieces of plastic that you might find in cosmetics, for example. One thing we do know for a fact is that plastic is one of the most prevalent sources of pollution in our oceans. Recently, in fact in the last month, there's been research found by people from Plymouth University in Britain. I think I got that right. I think it was Plymouth. In Britain, that found microplastics in every single marine mammal washed up on shore. Excuse my French, but holy shit, that's insane. However, in saying that, we're still not sure what effects the microplastics had on these marine mammals, if they had any effect at all. As the researchers stated, they're not sure if these organisms had died from disease or if the microplastics had a bigger influence than what we first thought possible. But the fact remains that plastic is so prevalent in our oceans that organisms are consuming them, and we don't know if these microplastics move up through the food chain quite regularly. And what I mean by that is we're not sure if organisms at the lower end of the food chain consume microplastics and organisms from higher tier positions then consume the lower order species and then take up those microplastics that were taken up by its prey. We're not sure if that has any effect at all on higher order organisms. Alright, second topic or question, not sure what I'll call this, but this one's an interesting one because whale sharks seem to be consuming more plants than animals. So it seems like the vegan community has found itself a powerful advocate for stopping us barbarian meat eaters. The University of Tokyo discovered that whale sharks seem to eat more plant materials such as algae during periods of starvation, and this could be due to, but not limited to, long periods of migration where they may not eat a lot of food getting from one place to the next. You may be wondering, how did they discover this? Well, isotope analysis. You're probably wondering, what in the is an isotope analysis? An isotope analysis. Well, let me explain that to your faces. Isotope analysis is one of the most powerful tools in discovering an organism's diet. And this is achieved through understanding their isotopic signature in the animal's tissue. And this isotopic signature is found through the stable isotopes, such as carbon, nitrogen, or sulfur, found, as I said, in the organism's tissues. And this is exactly what researchers at the University of Tokyo did. They took routine health checks on eight. I don't know why I need to count that. 8 different whale sharks in Okinawa waters. And they found through these routine health checks, by taking blood samples in the pectoral fins, that the isotopic signatures reflected more plant material than animal material. Which is quite, I guess you could say, controversial in a sense that whale sharks are basically been known to eat only krill, fish eggs and small fish species. So finding that they like to consume more plant material during periods of starvation is real interesting, and needs to be researched more, because we gotta change the books. We gotta fix up all those books that say that whale sharks eat krill and whatnot, because yes they do, but they also eat plants. Fascinating stuff. Actually, it's quite cool. Real cool. In fact, it's not the first time that a shark has been known to eat plant material on the side. The bonnet head shark likes to eat a lot of seagrass and algae as a side dish to its shellfish diet. Not the first time. Probably won't be the last. Alright. Third topic, question / is murky waters make fish anxious? No brainer. Quite obvious. Because I probably wouldn't, as a animal myself, wouldn't want to hop into a brown, murky, sediment-filled, disgusting water. What was I going to say? I was going to say something. That's right. I'm not going to jump into a murky, gross, disgusting water and swim around, because I don't know what's in there. And that's just basic survival instinct. But what these researchers found was quite interesting. And to some of you is probably, duh, you idiot, who cares? I already know that. I don't need a researcher to tell me. Yeah, well, you know what? I'm telling you right now, so listen up. The researchers at James Cook University not only found that fish are more cautious, but these sediment-filled waters also affect their growth rates, as well as possibly their health. So how they tested this was they actually simulated a prey attack in 2 different conditions. First being murky, second being that the fish were placed in clean, reef-filled condition. Clear water, perfect, 30-meter viz, what you want on a dive. You go out, you're like, hell yes, 30-meter visibility, I'm gonna see everything. I'm gonna take some great shots. It's exactly what was going through the fish's head, So what they did was, when they simulated this attack, they found that the fish in murky waters reacted way faster than the fish in clear waters. What the hell? You're telling me that a fish that's sitting in clear water can see its prey coming from a mile away, is probably thinking, nah, that shark, that shark or that larger fish, it's not going to attack me. It's coming straight towards me, but maybe it's one of those like door knockers. Maybe it's wanting to tell me about its Lord and Savior, fishy Christ or something, And then this other murky dude saying like, that guy looks fishy, I'm out of here. No, I'm not, I'm not sticking around. I'm going skis. See you later, You're telling me that that's the story here. What? That doesn't sound bad, right, though. Increased anxiety, increased survival rate, you're not going to take any risks. You're wrong. Although they have increased survivability in these conditions, they also have increased energy output, and that means that they don't have enough energy for reproduction or growth, meaning that their growth is stunted and then probably not going to breed as much as what they should be to increase survival rate for future generations. How do we fix this? Well, I'm not spite. What was this? My best response would be mitigate the amount of runoff that's going into the waters. Stop putting useless crap in the water, such as grey water and storm and grey are the same thing. But stop chucking grey water into the bloody ocean, and just be conscious about what you're putting into the ocean. Alright, so my battery died. Both batteries were dead actually, so I partially charged this one because I wanted to get this done, out of the way. To give you some idea of how long that took, I started this at 9, had lunch at 12, it's now 12:10. So yeah, let's just finish this off. Final question? I don't know what these are. Are these questions? These are not questions. These are more like topics. Final topic is declining shark numbers in Queensland, Australia. Now this hits home, not because I live in Queensland, Australia, but because it's that I love sharks. Actually, let me change this. This battery keeps dying for some reason, and I'm not sure why that is. Hearing that these animals have been in a 50-year decline, you heard me correctly, 50 bloody years of decline in Australian or Queensland coastal waters. Let me tell you, I was fuming. So this comes from the majority of drum lines along Queensland's coast, and these are only there to prevent human-shark interaction. Why would you want to prevent that? These animals are awesome. These drum lines cover, I think it was like 1,700 kilometers of our coastlines, and it's not even guaranteed that this is going to target shark species anyway. Like, you're probably going to hit dolphins, you're going to hit a bunch of other species, like even birds most likely. It's nuts. So seeing that there's been a 50-year decline in shark species along the Australian coast is mind-blowing. Research at UQ School of Biological Science in Australia identified that great whites, tiger sharks and hammerhead sharks are at 74 to 92% decrease in population. That's a lot. Not only are there a massive decrease, but average sizes of sharks are also decreasing. So we're seeing smaller and smaller shark species as the years go by. The crazy thing is that sharks play probably some of the most important ecological roles in our ecosystem. They help maintain and upkeep a crazy amount of biodiversity in our reefs. Remove the sharks, everything cascades. Everything falls. So if you see a shark out in the waters, that's a good thing. That means that that area is healthy. That ocean system or that marine ecological system is healthy. I could talk about this for ages, but I'm not going to, because this video is probably going on long enough. Instead, I'm going to wrap it up here. I hope you liked that second Q&A / I guess topic video. I love doing these. These are so much fun. So I will continue doing these, and the next one will be another Q&A based off of your questions. So next time I put that up on Instagram, answer, give me something to talk about, and we'll make another dope video. Without further ado, my name's Sloppy Dugong, aka Zach. Remember to educate and don't eradicate, and I will see you in the next video.